We'll move on to the next presentation, which is extracting structured information from the Eu-Acquis on information provision activity requirements. How much CO2 do you need to get the job done? For this, we have Dominik Skotarczak, who is the IT service officer at the Publications Office of the European Union.
Thank you for the introduction and good early afternoon, everyone. My name is Dominik, and today I have the pleasure of telling you about our work on extracting structured information from the Eu-Acquis on information provision activity requirements, or IPARE for short. And this is a technological approximation of these type of information extraction tasks on this corpus, but it is also about some environmental aspects, as you will see later in the presentation. Without further ado, let us start with a use case, and I'm really glad that we are in the same section with my fellow speakers, because you are already familiar with this metadata part of a legislative act on EURLEX. And now if we employ the IPARE methodology, we could, for example, have specific mentions of clauses right underneath or another part, so sort of as an assistant that lets you go directly to a specific recital, paragraph within an article or an article while you're starting to read a legal act. And if we go to one of those articles, I chose Article 96, we would also like to have a specific paragraph highlighted and some extra information underscored. In this case, it's a providing entity, which is the Commission, and an expression of frequency, which is every 2 years. But more about it in the next few slides. So here you can see another text snippet from EU legislation. And so what we're really interested in here is first detecting the part of this text that mentions this information provision activity requirement, as you can see in bold in this slide. And we also want to extract some extra information about this activity. And within IPARE, we focused on 4 slots, which are the providing entity, the target entity, the deadline, and please note that the deadline here is actually standardized to a common format to help us analyze and work with this, this data later on, and an expression of frequency that also comes in a standardized format. Now, this is the lengthiest slide in this presentation, but please bear with me. Information provision activity is how a providing entity communicates or provides information to a target entity. The providing entity is or may be obliged to perform an information providing activity which involves systematic or one-time actions such as reporting, disclosing, notifying, providing, certifying, publishing, or transferring information. And here we distinguish between primary and secondary information, where the former includes information on the key actors involved, information activity type, and activity-related deadline and frequency, whereas the latter encompasses details such as language and format of information, information process-related technicalities, detailed descriptions of the to-be-provided information, and all of that goes beyond primary information was not the focus of IPARE. Now, you might be asking yourself, how do you actually run an IPARE? Well, if you've been listening carefully enough, you can probably tell that there's 2 tasks. The first one is detection, which we call subtask 1. And here we want to determine whether a text fragment contains a mention of information provision activity, and more precisely, a mention of primary information. And once that is done, we then move on to the actual extraction, which is the task where we extract primary information on the providing and target entities, as well as frequency and deadline if they're present in the text. And so to understand IPARE as a task and also how different technologies can aid this extraction, we created a benchmark corpus. The corpus comprises 1,212 sentences that are on average 40 words long, and the 2 annotators that were tasked with the creation of this benchmark agreed in 90% of the cases then 43.2 sentences include a keyword that strongly suggests that there might be an information provision activity and an expression of deadline or frequency. But nearly 20% of those sentences did not include any keyword at all. And if we look at the statistics of the benchmark, 55% are positive sentences that include a mention of information provision activity requirement. Within those, over 90% include a providing entity, nearly 90% include a target entity, then just short of 60% include an expression of frequency, and slightly more than 60% include an expression of deadline. So which technologies can we incorporate for IPARE? So we divide this again into the two subtasks. For detection, we specifically looked at the baseline, the classical machine learning, transformers, and LLMs. And for extraction, we looked at knowledge-based and LLM approaches. And that doesn't mean that classical machine learning or transformers are not capable of running these extractions. It's just that our benchmark corpus was too small to look at those technologies. And so we have concluded that actually classical machine learning is the most suitable solution for detection, and that is despite it being a runner-up in terms of performance. And for those of you who are more technical, the F1 score was 0.02 short of the best performing LLM. But classical machine learning is faster and it is easier to maintain, and it can be improved with more annotated data and more sophisticated features. We only looked at some rudimentary features within this approach, and on top of it, it can be hosted locally, which has massive implications for sovereignty. Now, for extraction, we concluded that a hybrid approach is the most suitable. And that is because with this approach, we can capitalize on certain advantages that these two approaches have. While the knowledge-based approach is more precise in judgment, it might miss some fields. And so what we gain with the LLMs is this additional step forward to cover for those cases. But there's a caveat here, and that is that LLMs might struggle with standardization and formatting, which is crucial for interoperability. And here you have an example of what we're after. We're not only interested in an extraction of the text snippet, we actually want to have it standardized to a format that is later on workable. So there should be a combination of the two. Alternatively, the approach could also be selected based on the use case. And that could come after considering the desired metric, be it precision, be it recall. But it is also important to consider speed, cost, and environmental footprint. And I think this is the perfect transition to the next slide. To answer this question about LLM energy consumption, we looked at the literature to find that there was a research team that reported that generating an average of 10 tokens, which is about 7 words, give or take, 1,000 times across 6 tasks consumed nearly 0.05 kilowatt hour on average. And that is an equivalent of over 2 average fully charged smartphones. So we have to be careful with the technology that we're using. It is also true that it is very difficult to estimate LLM energy consumption, and that is because there are different sources of it. There's training, there's inference, and as a user, we only have a limited ability to influence the training energy consumption, but we can do something about the inference consumption. And actually, there are many other aspects that should be considered when calculating this footprint. And the Mistral research team reported an additional 15% of those consumption sources for their Mistral large model. Then it is also true that generative tasks require more energy than discriminative tasks. If you don't know what a discriminative task is, it is, for example, IPARE detection. And then the research team also reported that multi-purpose models require more energy than single task models. So it was about 30 times for text classification per 1,000 queries. So what can we tell about energy consumption for IPARE? Well, for starters, detection on a single sentence is less power consuming than extraction. And baseline knowledge-based and classical machine learning consume less energy than transformer models, which in turn are surpassed by LLMs by several orders of magnitude. And so you might be asking yourself, how can we minimize this IPARE inference cost? And so we arrived at this trade-off between cost in production and annotated data. And here it's important to mention that costs do not need to be financial. They can also be computational, that influences the speed of inference, and also environmental, so the carbon footprint. If we combine LLMs and knowledge-based approaches, we can shift down on the axis of the cost in production, but we need a little bit more data to work with. Now, it is also true that LLM inference is expensive, but it actually requires less annotated data. And there might be cases where we work on a subset of documents, a smaller number of documents, we don't have the data, and we want to infer something about them quickly. LLMs could be our friends then. But then it is also true that when we want to run it at scale, classical machine learning is cheaper and consumes less power in production, but it also requires more annotation to begin with. And annotation takes time. So that's another factor to consider here. And if you're interested in our work, I encourage you to look at the full technical report, and you can find much more information there. And right now, I would like to show you an application of the IPARE methodology on Eu-Acquis. So you'll see here that we created this demo browser extension for similar clauses, empowerments and reviews to be exact. There are two different types of empowerment acts as well. And this is running from cache, so it usually takes more time. And you can see here that we can get the exact location of empowerment clauses as suggested by artificial intelligence. You can see their little tags. They mean delegated or implementing acts. That's an implementing act clause in paragraph 10 of Article 4. Then we can also look at an example of an empowerment that is not a delegated or implementing act. This is at the Court of Auditors that shall have the power to audit. And one more example, that will be the delegated act. Here we go. Now the most interesting part is that with LE subsections, we can use it across 24 languages. So I picked French first to show you how it works. We can run the same extension. It's in English for the simplicity of things with this demo, but you will see that it actually runs on French as well. And here we go, c'est acte d'exécution. So I'll skip the last language that I wanted to show you to save some time. But feel free to approach me in the demo part of today. And here are the sources for the environmental footprint if you're interested in that. And please scan the QR code if you're interested in the technical report. And the last word that I want to say is that tomorrow we have a presentation about the extraction part and how to enable this. It's called named entity recognition in the legislative domain, 10:30, same room. So I encourage you to participate as well. Thank you.
Thanks, Dominik. So let me check first if we have questions here in the room. Any question? No? Okay, so we'll go to Slido. First question from Slido. How difficult is it to obtain enough annotated data for testing classical machine learning and transformer models for extraction tasks, considering their potential to reduce production costs?
So that's a difficult question because we can't tell ahead of time. We would need to first see how much data is required to actually adjust the weights of a transformer models or actually compose the weights of a classical machine learning model. We didn't go into that because it's a considerable amount. But for example, for detection, we had for transformers, we had 4/5 of the 1200 sentences, so about 80%, because we run a cross-fault validation there. And so we already had to freeze the a pre-trained model and only append a classification head on top because of the amount of data that we had. And how much data it will take for extraction for a transform model, it's hard to say, but I would assume that if it's this complex, we'll need a more chunky head on top of the pre-trained model, or even we'll have to use some other methods to make those weights within the pre-trained model adjusted for our task.
Okay, thanks. Next question from Slido. Can you share insights on how IPARE can be continuously monitored as EU laws evolve, and what strategies exist to enhance the system's adaptability?
Well, here we have to rely on the definitions suggested by the legal experts and the users. And within IPARE, the process was first agreeing on a definition for information provision activity requirement and what it actually stands for. And so as EU laws evolve, I would imagine a group of technologists and legal experts working together on adjusting the definition, re-annotating the data if it's necessary, and redesigning the prompts, for example, if LLM is the go-to technology, or redesigning the lexico-semantic patterns if it's the knowledge-based, or both if we're opting for a hybrid solution.
Great. Well, thank you so much, Dominik, for walking us through IPARE, taking a quick look. Any last questions? No. Okay. So how about a round of applause for Dominik?